This meeting is being recorded.
For problem 12 from chapter 13, we're asked to assign a name for each of these compounds. And if there is a chiral center present, we're asked to make sure to assign the configuration and provide that at the beginning of the name for each of these compounds. So it looks like we will have to do that in each of the following compounds. So let's take a look at A here. And we know that there's two methods for naming epoxides. And in one method, our parent would be propane. So we would see 1, 2, 3 carbons in our longest chain. And the oxygen is connected to the parent at carbon 1 and 2 and named as an epoxy substituent. So we would name this compound as a 1,2 epoxy. And then we also have at carbon 2 a phenyl substituent. So 2-phenyl propane. And then we also have to, as mentioned, assign configuration to this chiral center. So if we were to assign priorities here, we would see this direction would be 1, this direction will be 2, and then this direction will be 3 with the phenyl group. So our lowest priority is already on a dash, that methyl carbon. So this looks like an R configuration. So we would name this as R12 epoxy 2-phenyl propane in our first naming system. And then if we were to use the other naming method, our parent would be considered an oxyrane. And we have to assign our numbering a little bit different here. So we still have a phenyl substituent, but now our carbon 1 would be on the oxygen, and this would be carbon 2, and this would be carbon 3 here. And now we would name this as our oxyrane. We would have 2-methyl, and then 2-phenyl. Oxyrane. And again, we would have that R configuration out in front. So these are the two names for compound 1. Let's take or compound A. Let's take a look at compound B here. And again, in our first naming system, we want to name our longest carbon chain here. So this would be a heptane parent. And again, in that first system, this is an epoxy substituent, and it's between carbons 3 and 4. So this is a 3,4 epoxy heptane. And we also need to assign chiral configuration to these two chiral centers here. So let's start with carbon 3. We'll see that that's R, and then carbon 4 will also be R. Nope, we've got our dash there. So let's assign priorities here and confirm that these are R configurations. So we see that we also have a hydrogen here that would have to be on a wedge because our other 3 planes are already taken up, our other 3 dimensions. So our lowest priority being in hydrogen, not being on a dash, we're going to have to invert whatever our decision is here. So we would say this is group 1, this is 2, this is 3. So this looks like it's S, but we know that we would have to change this configuration to R because of that hydrogen not being on a dash. So that's why 3 will be R. And then we can quickly do the same thing over here for our chiral center at carbon 4. So our highest priority would again be this direction here, and then we have 2 going this way, 3 going this way, and our hydrogen is already on a dash here, so this is R and remains R. So our first naming system, we have 3R, 4R, 3,4 epoxy heptane. And going into our second naming system, again, we'll name our parent as an oxyrane. And we have then an ethyl substituent over here. Let's confirm our numbering of carbons here in our oxyrane structure before we name our substituents. So we would have carbon 1, and then over here would be carbon 2, and then here would be carbon 3. So we have a propyl substituent, 1, 2, 3, on our carbon 2, and an ethyl substituent, and now we need to name our carbons 2 and 3. And let's add in our substituent so far. So now we need to name our chiral centers on carbons 2 and 3, and we're going to see that we have 2R and 3S. So let's confirm carbon 2, our highest priority is here, so 1, 2, 3, and again that hydrogen's already on a dash, so that looks like it's R, and then we go to our carbon 3, and our lowest priority is on a wedge, so this looks like, again, that would be in our configuration, but we know that we need to change this to S. So we end up with 2R, 3S, 3-ethyl, 2-propyl oxyrane in our second nomenclature system. And let's do molecule C here as well. And once again, we want to name this as our longest carbon chain. So we'll have a pentane parent here. And on carbon 4, we have a methyl substituent, and we name our epoxy substituent on carbons 2 and 3. And then we have to name our 2 chiral centers. So we should end up with 2R, 3S, and then we have 2, 3 epoxy, 4 methyl, and then pentane. And in our second naming system, we're going to name this as an oxyrane. So again, we want this to be carbon 1, this will be carbon 2, this will be carbon 3. And again, we have 2 chiral centers, so we would end up with a 2S3R, and we could name the substituent as a 2-isopropyl, 3-methyl oxyrane. Or we could also name that isopropyl as a 1-methyl ethyl. So that would change this to be a 2, now it would be a 2R, 3S, 2-methyl, 3, and then 1-methyl ethyl. So this changes the order of our naming, methyl ethyl rather, and then oxyrane. So see if you can use these steps and find the names for compounds shown below.